Hello everyone, welcome back to Newsday. This is the third episode, and today, hold on one second, let me try and change up the atmosphere here. Let's try something different. Yeah, let's try this. So, for today's episode, there's a bit of a medical theme going on. I found 3 fascinating articles, so let's just jump straight into it. This first story comes from 3dprinting.com, where surgeons in India used 3D printing to plan and execute a successful surgery. An infant in Delhi had a medical condition called, you can feel free to try and pronounce this. What essentially the condition is the skull develops improperly. So if you look at this image here, the skull on the left is what a normal skull should look like. And the spaces here in the center are actually normal because the brain is growing and the skull needs to expand and then fuse around the grown brain. However, infants with this condition have a fused skull which will not allow for brain growth. Serious cases of this condition can cause blindness, development issues, and other neurological problems. The surgery to treat this and open up new sutures in a fused skull is very dangerous. So what these surgeons did is they used 3D printing to print out a model skull of the infant. They used scans to get exact measurements, and holding printed skulls, they were able to precisely plan the surgery. The main surgery was completed in 7 hours, and the patient was sent to the ICU for 2 days to be observed and provided with post-surgery care. After they returned to the ward for only a couple of days, the infant was discharged on the 6th day and is now making a recovery, which is expected to be a full recovery. So this is another success story that might not have been if it wasn't for 3D printing. On the topic of bones, our next story, scientists use an ink with calcium to 3D print bone with living cells. Scientists from Sydney have developed a ceramic-based ink that may allow surgeons in the future to 3D print bone parts complete with living cells that could be used to repair damaged bone tissue. Using a 3D printer that deploys a special ink made up of calcium phosphate, the scientists developed a new technique known as ceramic omnidirectional bioprinting in-cell suspensions, or COBICs, enabling them to print bone-like structures that harden in a matter of minutes when placed in water. So 3D printing bone structures is actually not a new phenomenon and has been happening for a while. But the biggest breakthrough here is the fact that it can be printed in a room temperature without the need for a furnace or the toxic chemicals for setting. The other major breakthrough here is that these prints can be done with living cells because of that. This means rather than printing a new piece of bone and then placing it into the patient, theoretically you could print new bone directly into a patient. Here is a short video from the University of New South Wales to explain a little bit about their research.
First example of integrating ceramic materials that emulate many aspects of native bone with live cells. This really opens up the opportunity where you may be able to actually directly print a patient's bone within a cavity. And so what I mean by that is during surgery, if they have some bone resected for disease or if they have a tumor taken out, then we can actually take scans of that bone and then put that onto the printer and then directly print within a cavity of a patient with their own cells being there. And those cells then may be able to engraft and form native bone naturally. And that's going to speed things up with respect to surgery time. It's going to enable a lot of reduction in current suffering and also perhaps, hopefully, ultimately, save lots of lives.
If you can print bone structure with living tissue, and as we've seen before, you can print other types of cells, I like to imagine that if someone had to lose their arm, maybe there's a future that's not so far away where you could get another arm printed and attached. And our last story, Korean scientists create low-cost 3D printed testicle replacements. This is for those who maybe lost a testicle due to an accident or testicular cancer. Synthetic replacement testicles have been around for quite a long time. However, the modern technology here allows the cost to be driven down much, much further. Not mentioned in the article, but I assume to be possible, is potential testicle customizations. I'll leave it to you to imagine what those customizations might look like. The Korean firm that developed these 3D printed testicles is called AMS, and they have an exclusive license to provide these prosthetic testicles. The price right now is a little over $700, which is much lower than any other synthetic testicle on the market. So those are the 3 stories for today. If you have any suggestions for other content you'd like to see, then please leave a comment below, and I look forward to seeing you next week. Bye.